equations with fractions, let's start simple. Let's just review the process of what we do with equations. What is it that I need to know in this particular equation? Really? What x is. Good. I need to find out what x is. So the challenging part is that x is kind of like on this part of the equal sign where I've got an addition sign and everything else. It's not here. See, if it were here, it was, oh, okay, x is there. I just do what's on the other side, and I get it. So there's one key word that I think of when I think of equations, and it's what? Starts with an O? Opposite. We want to think opposite. Okay? So I want to focus on the side of my variable, and what's the verb? What's the action that's happening there on the same side of my variable? Josiah. What's the action? What's going on there? We are adding how much? We're adding 9. The opposite of adding 9, subtracting 9. I'm going to do that where? Both sides. When I subtract 9 here, it's x plus, what is 9 minus 9? 0. So I get x by itself. 16 minus 9 becomes 7. How do I know that 7 is the solution I'm looking for? And that works sometimes, but we also need a process that we could use every time that'll work. It's easy now because you knew right away once I put this up here that our solution was going to be 7. Okay? It's not always that easy to just look at it. So that's why we need the process. So we need to think opposite. Sometimes you'll have it written like this, which, okay, same general concept. My goal is to get x by itself. So what is on the same side of my x? What's on the same side? What's the action here? Trinity. Adding what? 16. Now, we could either call it adding 16, or what kind of a 16 is this? Is this a positive 16, or is this a negative 16? Positive. How would I get rid of a positive? Subtract, right? The opposite. So let's subtract 16. X would then equal 16. I can change the order if I want. If I wanted to rewrite it, I could do that if I wanted to, because I can add in any order. Remember, the commutative property of addition tells us I can add in any order that we want to. Okay? But just understanding what's there and doing the opposite. Consequently, if we had x minus 6 is equal to 12. The process tells us we need to locate our variable, we need to find out what's happening on the same side, and do the opposite of it, which in this case is what, Sydney? What's the opposite of what's going on here now? Adding how much? We're going to add 6 to both sides. Because when I'm at a negative 6 and I add 6, it puts me back at 0. X plus 0 is just like saying x. 12 plus 6 is 18. How do you know? Plug it back in. 18 minus 6 is equal to 12. Now, some people fall in the trap, and they look at it, and Maddie, that's kind of the problem, is some people looked at this right away and said, oh, x minus 6 equals 12. It's got to be 6. Because they see the 12, they see the 6, and their brain tells them that's the relationship. Well, it doesn't make any sense if you plug it in. 6 minus 6 doesn't give you 12. Okay? That's why we use the process and take it that way. Now, what today is going to have you do is use that knowledge from equations, doing opposite, and they're going to apply it to the fraction problems that we've been working on since the end toward the end of last week, middle to end of last week. For example, n plus 1/3 is going to equal 11/12. Okay, so setup is going to be extremely important. Making sure I know exactly what I have to do, then execution comes in. So my variable in this case happens to be an n. What's happening on the same side of n? What's the action here? We are adding 1/3. So the opposite of adding 1/3 is going to be subtract 1/3 from both sides. Now there's a slight problem. In order to add or subtract with fractions, they need to have, Trinity, common denominators. So I will just have to set it up and set it up with common denominators, which in this case will be 11 on top times 4. 11 minus 4, 7/12. So n equals 7/12. Have you subtracted with fractions already? Yes. So the setup is going to be important, that you make sure what it is you're doing. Here, I'll give you one to try. A plus 2/5 is equal to 13/20. Okay, so the opposite of adding 2/5 will be subtracting 2/5 with 20 as a common denominator. Times 4 gives us 8 on the bottom. 13 minus 8 is 5. And 5/20 simplifies to 1/4. Very good. Very good. Now, of course, they will throw in some mixed numbers. Shouldn't be too big of a deal. If I can find one. K minus 4 5/6 is equal to 2 1/4. Try it.